Hi everyone, a very good evening and welcome to today's session. This is Gayatri here, and today the topic that we are going to be discussing is number system and number series from Quantitative Ability. So as you all know, these are concept-based sessions that we are organizing exclusively for titanium students. In each session, we will be taking up topics from different subjects, and we will be teaching you the basics that you should know from that particular topic, and we will also solve a few questions from these topics. So in today's session, the topic, as I said, the first topic that we are going to be doing is number system. Now, number system is a very, very basic topic from Quantitative Ability, and definitely one or two questions in your exam, any exam, be it bank, SSC, okay, you can definitely expect one or two questions from this topic in your examination. Now, coming to number system is all about learning about numbers, right? Now, numbers are generally classified into two main types. One are real numbers and complex numbers. Now, for our consideration, for all aptitude exams, we need to take into consideration only real numbers. So, we will discuss about real numbers today. Now, real numbers can be broadly classified into two types, rational numbers and irrational numbers. So, I'll just share my screen. I've just put down these information in a PPT so that it's easier for us to skim through these basics, and let's not waste too much of time talking about these basics, okay? See, any number which can be represented of the form P divided by Q, where Q is not equal to 0 and P and Q are integers. Such numbers are called as rational numbers. Now, let's say 1, the number 1, correct? So, you can say it is 1 by 1. It's a rational number. Number 3, that you can say it as 3 by 1. Or let's say the number 2.5. What is 2.5? It is nothing but 5 by 2. So, all these numbers can be represented in terms of P by Q, where Q is not equal to 0. Now, so what are irrational numbers? Numbers which cannot be represented in this form are called as irrational numbers. For example, you have numbers like pi, correct? Then you have root 2, root 3, etc. Correct? Such numbers are called as irrational numbers, or generally non-terminating decimals, etc. are called as irrational numbers because you cannot represent them in this form. Now, then you need to know what are natural numbers, what are whole numbers. See, why are these definitions very important? Because at times in exams, they might make use of these terms, whole numbers or natural numbers. At that point, you should not say, I don't know what this means, correct? So, that's why we are discussing all this. So, all the set of numbers that start from 1, 2, 3, 4, etc. till infinity, such numbers are called as natural numbers. Now, the set of numbers starting from 0, 1, 2, 3, etc. till infinity are called as whole numbers. Similarly, what are integers? The numbers starting from minus infinity, that is all the negative numbers, correct? Minus 3, minus 2, minus 1 and 0, and the positive integers 1, 2, 3, 4, etc. All these form the set of integers. Even numbers, all the numbers divisible by 2 are called as even numbers. Now, then we have odd numbers. What are odd numbers? Numbers 1, 3, 5, 7, etc. are called as odd numbers. See, these are definitions that you know. I have just written it down so that we are able to brush up the basics once again. Now, next most important numbers that you should know is prime number. What are prime numbers? Prime numbers are numbers which have only two factors, correct? It's a number which has no other factor other than 1 and the number itself. Such numbers are called as prime numbers, and the smallest prime number is 2. Okay. Now, what are composite numbers? Numbers which have factors other than 1 in itself. They are called composite numbers. Let's say you take 4. What are the factors of 4? Factors of 4 are 1, 2 and 4. So, now this has more factors other than 1 and the number itself. Such numbers are called as composite numbers. Okay. Again, what are factors? See, let us say you have a number A, okay, and when you are dividing this number A by some other number B, and the remainder that I get when I do this division is equal to 0, that means that this B is the factor of A. How can I explain this? See, let us take a number 8. Now, I am dividing it by 4. When I divide 8 by 4, I get the answer as 2 and my remainder is 0. So, I can say that 4 is a factor of 8. See, definition of a factor is very, very important when we solve questions on HCF, correct? Again, you will have questions where they ask you how many prime factors are there for this number. So, you should know what a factor is before you solve such questions. Okay, I hope it is clear. When you are dividing, that is, factors are numbers which will divide the given number completely in such a way that the remainder is equal to 0. Okay, now next other important definition that you need to know is what is a coprime. So can any of you tell me what is a coprime? See, I have given you examples also of coprimes. So if you have two numbers whose HCF is 1, you call that as coprime. Now let me give you an easier definition, because we have not yet gone to HCF, right? So if you are new to this, coprimes are two numbers. Take two numbers, with respect to each other they are prime numbers, but if you take them alone they needn't be prime numbers. So such numbers are called as coprimes. Or if you have two numbers, they have only one common factor between them, that is 1. Other than that they have no other common factor between them, but when you take them alone, coprimes. Okay, so or they are prime numbers with respect to each other. So let us take 22 and 9. See, is 22 a prime number on its own? No, it's not. Is 9 a prime number on its own? No, it's not, correct, because they have different factors, 11, 2 and 1. So this will have factors 1, 3. Okay, now if you if you take these two numbers together, the only common factor between them is 1. So such numbers are called as coprimes. Yes, or if you know the concept of HCF, see, HCF is nothing but the highest common factor. So what is the only common factor here? It is 1. So here the highest common factor between the two numbers is 1. So such numbers are called as generally coprimes. Okay, now next thing. Now see, these are the basic definition of the numbers that you should be aware of. Now the next important thing that you need to know is the divisibility rules. Now I am sure all of you know the divisibility rules by heart for all the numbers starting from 1, 2, 3, 4, 5, 6, 8, 9, 10. Okay, I'm sure all of you will know that. So I have just listed down the rules here on the screen, and I'll just give you a number. Tell me if it is divisible by the given number or not. Okay, and then we will go about. See, I'll teach you the divisibility rules for the numbers like 7, then 13, 19, etc., which is actually the little difficult ones, which you might not know very easily. Okay, other than that, all the other ones you should be able to say. Now, what is the divisibility rule for 2? All even numbers are divisible by 2, that you know, correct? Like any number ending with 2, 4, 6, 8, 0, all these are divisible by 2. What is divisibility by 3? If the sum of the digits is divisible by 3, then the given number is divisible by 3. Now let me give you a number. Can you tell me if this is divisible by 3? 3, 4, 3, 2. Is this divisible by 3? How do you do this? See, add the digits. 3 plus 4, 7. 7 plus 3, 10. 10 plus 3, 12. So when I add the digits, I get the answer as 12. 12 is divisible by 3. 12 by 3 is 4, correct? So this number is divisible by 3. So add the digits and check whether the sum is divisible by 3 or not. Now let me give you a question for divisibility by 4. Take this number, 5, 7, 4, 2, 8. See, how do you say that a number is divisible by 4? If the last two digits of the number is divisible by 4, then the number is divisible by 4. Here, last two digits is 28. 28 by 4 is 7. So 28 is divisible by 4. So this number is divisible by 4. Now to check if a number is divisible by 5, last digit has to be either 5 or 0. I'm not even going to explain that. Next one, divisibility by 6. So a number is said to be divisible by 6 if it is divisible by 3 and 2. Okay, let me give you an example. Let's take 3, 4, 3, 2 itself. The same number that we chose up, correct? See, 3, 4, 3, 2 is an even number, so it is divisible by 2, correct? It is already divisible by 3, so it is divisible by 2 and 3, so it is divisible by 6, okay? So that's how you check for divisibility by 6. Now, how do you check whether a number is divisible by 8? Look at the last 3 digits of the given number. So if you have a number like, let's say 4, 5, 3, 2, 8. Now, to say if this number is divisible by 8 or not, you have to check whether these last 3 digits is divisible by 8. So if you see, this is 41 into 8 is 328, correct? So the last 3 digits is divisible, so this number is divisible by 8. Similarly, to check for divisibility by 9, if you have a number like 729, add the sum of the digits, the sum should be divisible by 9. When you add here, you get 7 plus 2, 18, 18 plus 9, that is 27, 27 is divisible by 9, so this number is also divisible by 9. Now divisibility by 10, if the last digit is 0, it is divisible by 10. All of you know that. Now let's look at the next set of numbers. Okay, again, if you have to check if a number is divisible by 12, check whether it is divisible by 4 and by 3. Similarly, to check if a number is divisible by 14, check if it is divisible by 7 and 2. Now let's come to the remaining ones where you might not be very sure about the divisibility rule because we don't use it it's not very easy, right? Now let's see. The first one is to check for divisibility by 7. Let's discuss 7 first. Now let's take any number, okay? Give you a number 11347. Okay, how do I check if this number is divisible by 7 or not? So the method that you have to follow is this. Always take the last digit, multiply it by 2. What is the answer that you get? 7 2s are 14. Now subtract this 14 from the remaining numbers. What is the remaining number you have? 1134. Subtract this 14 from this. 1134 minus 14 will give you 1120. Correct? Now again take the last digit, multiply it by 2. So what answer do you get? You get 0. Correct? Now subtract the 0 from the remaining digits. So 112 minus 0 is what? 112. Again take the last digit, multiply it by 2. So 2 2s are 4. So 2 2s are 4. Now subtract this from the remaining digits. So 11 minus 4, that is equal to 7. Is 7 divisible by 7? Yes, definitely. So this number is also divisible by 7. That's how you do the divisibility of 7. Let us take another number. If you have a number 245, okay, last digit is 5. 5 into 2 is 10. So 24 minus 10, that is equal to 14. 14 is divisible by 7. So this number is also divisible by 7. So the rule to check for the divisibility by 7 is multiply the last digit by 2, then subtract it from the remaining digits. Keep doing that till you arrive at a number which you can say by looking itself whether it is divisible by 7 or not. Now next let us look at divisibility by 11. Now divisibility by 11, how do we say? A number is divisible by 11 if the difference in the sum of the alternating digits of the number is either 0 or a multiple of 11. What does that mean? See, if I have a number 675356. So add the alternating digits. 6 plus 5 plus 5. That is 6. What is 6 plus 5? 11. 11 plus 5, 16. So this adds up to 16. Now 7 plus 3, 10. 10 plus 6, 16. Find the difference between these two. 16 minus 16, that is equal to 0. So add the alternate digits of the given number and subtract the sum. The answer should either be 0 or 11 or a multiple of 11. Then the given number is divisible by 11. So here you are getting the answer as 0. So this is divisible by 11. Okay. Now next, divisibility by 13. Okay, odd and even number place. See, if you have, let me take a number 50661. Okay, look at the last digit. It's similar to how we did for 7. Multiply it by 4. So 1 into 4 is 4. Now add it to the remaining digits. In 7 what we did, we multiplied it by 2 and subtracted it from the remaining digits. For 13 what we do, multiply it by 4, add it to the remaining digits. So 5066 plus 4, that is equal to 5070. Correct? Again, last digit is 0. So 0 into 4, that is equal to 0. Again 507 minus 0, that is equal to 507. Then again you have last digit as 7. 7 into 4, that is equal to 28. Now you have to do 50 plus 28, that is equal to 78. Now 78 is divisible by 13, correct? 13 into 6 is 78. So this number is divisible by 13. Now next we have 17. So what is the divisibility rule for 17? So for 17 it is like this. See, let's say you have a number 3978. Last digit, multiply it by 5. Okay. So what do you get? 8 5s are 40. Subtract that from the remaining. So 397 minus 40, that is equal to 357. Again into 5. So what do you get? 35. Correct? So you have 35 minus 35, that is equal to 0. So it is divisible by 17. That is the rule for 17. Now similarly, let's look at 19. The rule for 19 is, let us take a number 101156. Multiply the last digit by 2 and then add it to the remaining digits. The answer that you get here, you get 6 2s are 12. Correct? So then do 10115 plus 12, that is equal to 10127. Now again multiply this by 2, add it to the remaining digits again. 7 2s are 14. So 1012 plus 14 will give you 1026. Multiply this by 2, you get 12. So 102 plus 12 is 114. 114 is divisible by 19, you know that. So this is divisible by 19. So these are the rules that are there. So let's look at the next thing. So these are the basic things in number systems that you need to know. And if you look at the questions that come from this section, no, the questions that you can expect will be questions based on numbers, interchanging of the digits, or doing some operations in the digits of the given number. That is one very commonly occurring question from this section. Then if you are appearing for exams like SSC, you can have questions wherein they will ask you for the power of numbers, like what is the last digit of 2 to the power 45. Questions of that type, or questions wherein you have questions like 2 to the power 50 divided by 7. What is the remainder for this? So these are the types of questions that you can generally expect from this section. Again, again another type that comes is about these. See, we just learnt these definitions, right? Co-primes, integers. So again, questions based on that. Divisibility rules. Okay, again about co-prime. So if you should know what a co-prime is to be able to answer a question from that. Similarly about factors, questions on factors. So these are the general types of questions that come from this section. So what I've tried today for today's session is I've tried to take at least one question from each type so that we get a complete understanding of the topic. Okay, so let me share my screen and we'll directly go about solving the questions. So if there is any concept that is required to solve the problem, I'll teach you the concept then and there. Okay, so let me share my screen. So first we'll start with a fairly easy question. The first question is there on your screen. Let me read the question. A number when subtracted by 1 by 7 of itself gives the same value as the sum of the angles of a triangle. What is the number? How do you do this question? You have to just frame an equation and get the answer. So what is this? See, if you take the number to be x, correct? You are subtracting 1 by 7x. The answer that you get is equal to the sum of the angles of the triangle. What is the sum of the angles of the triangle? Sum of the angles of the triangle is always equal to 180. Correct? So this difference is equal to 180. So what do you get? Find the value of x. Correct? So if you are taking LCM, you get 7x minus x, that is 6x by 7 is equal to 180, and these gets cancelled, so you have 30, or x is equal to 210. So the correct answer for this question is option B. Correct? So actually you should not write these steps. Correct? 1 minus 1 by 7, you should know it is 6 by 7. Directly you should be able to say 6 by 7 of x is equal to 30. Not even this step should be written. Okay? See, when such questions come, first thing that you see, a number when subtracted by 1 by 7th of itself. So 1 minus 1 by 7, correct? Or what is the number that you are looking at? 6 by 7th of the number. So 6 by 7th of the number is equal to sum of angles of the triangle, which is 180, or x is equal to, solve, that's all. Now next question. If the positions of the digit of a 2-digit number are interchanged, the number obtained is smaller than the original number by 27. If the digits of the number are in the ratio 1:2, what is the original number? See, one way to solve this question is try to look at the options and get the answer. Now, what have they given? Positions of the digit of a 2-digit number are interchanged. The number obtained is smaller than the original number by 27. So, I'll first solve it in the normal way how we do it, and then we will go with the options. Actually, the easier way to solve this question is just with the options. Okay, so generally because I'll solve it in the normal way so that you get an idea as to how to take the place value of numbers. Okay, now let's say you have a number xy, or not even xy, let's take a number 21. So here 2 is in the tens place, 1 is in the ones place. So actually if you expand this number, it is nothing but 2 into 10 plus 1, that is equal to 21. Correct? This concept I am sure all of you will know. So if you have a number xy, its actual representation is 10x plus y in terms of its place value I have written. Okay. Now what are they saying? The position of the digits are interchanged. So now what is the number? It is becoming yx. So what is the new number? It is 10y plus x. Now the number such obtained is smaller than the original number by 27. So what does that mean? 10x plus y minus 10y plus x. that is equal to 27. Correct? When you are subtracting the two numbers, you get 27. Now what is given? If the digits of the numbers are in the ratio 1:2. So let us say, see, you have two digits x and y, 1/2. If we take it this way, then I can say 2y is equal to x, or yeah, 2y is equal to x. In that case, I will get, if 2y is equal to x, I can say 18y minus 9y is equal to 27, or I can say 9y is equal to 27, or y is equal to 3. And then I get x is equal to 6, correct? Because x by y by x is 1/2. Okay, so that is the mistake that we have made. See, what is given here, no? If the digits of the number are in the ratio 1:2, this represents the number that is obtained after interchanging. Okay, see, earlier what I did was, I directly took x by y as 1/2, but they are saying y by x is equal to 1/2. That should have been the error. Okay, so this is how you actually solve it, but when you actually do it in the exam, none of this is required. I just try to do this just to make you understand, okay, the actual way of doing it. But when you actually do it in the exam, this is all you need to do. See, check with the options. Now they are saying that the digits of the numbers are in the ratio 1:2. Now check for the given number. See, all the three options, 3 into 2 is 6, correct? Similarly, 3 into 2 is 6, 4 into 2 is 8. Again, that condition seems to be there everywhere, even if you take the ratio for any number, be it the first number or the second number. Now what are they saying? When the digits are interchanged, the number obtained is smaller than the original number by 27. So take this one, option A first. So if it is 36, if the digits are interchanged, you are getting 63. But in the question they are saying, when you are interchanging, you should get a number smaller than the original number. So this is not the right option. Next, take the option 48. So if you are interchanging, again you will get a bigger number. So this is also not the option. Then you take 63. When you interchange 63, you get 36. And then the answer that you get is in the ratio 1:2 also. So this is your correct answer. Okay. Actually, when you do it in exam, you should be able to solve this question in less than 5 seconds just by looking at the options. Okay, I try to do it in the original way just to let you know how such questions are actually solved. Okay, because sometimes writing them in terms of the place value is also required. For this particular question, just looking at the options, we should be able to say what is the answer. Okay, so the correct answer for this question is option B, that is 63. I hope the actual way that we solved was also clear to you, because there was a confusion in between. So what you have to remember here is that if the digit, see, there is a number xy, I am now making it as yx, and when I make it as yx, they are saying that the ratio between the digits is 1:2. So this is what they have given. I accidentally took this is equal to 1:2, that's why we couldn't get the answer first. Okay, so they are saying these two numbers are in the ratio 1:2. Okay, let's look at the next question. So this question is a very common question. I see such questions posted by a lot of you in the discussion forum. Okay, what is the least number that can be added to the number 1020 to make it a perfect square? How do you solve such questions? This number 1020 is a fairly easy number. Sometimes the most common question that I get in the forum is, what is the least number that should be added to 7000 to make it a perfect square? Okay, if you go through the forum, you can see a lot of you post that question. So how do you solve such questions? See, again, most of the questions that I am choosing for these sessions, no, I am taking it from previous year exams, so that it is useful for you, right? It is some kind of practice for you. So you also get to know the question types that can come. So how do we solve this question? See, you have 1020. Now one way is to go with the options. Okay, see, 1020, if I add 4, what do I get? I get 1024. What is 1024? It is nothing but 2 to the power 10, or I can say it is 2 to the power 5 the whole square. That is 32 squared is 1024. Now 1024 is a number that all of us know. That's why we were able to find it very easily. Generally, let us assume that I don't know that 1024 is 2 to the power 10. Then how do I go about solving this question? So let us say the options are not given, or you don't know 1024 is 32 squared. So how do you generally approach this question is, take this 1020 and in your mind consider any two square values which you know for sure. Okay, see, 10 square, 20 square, 30 square, 40 square, this all of us know, correct? So 40 squared is 1600. Okay, what is 30 squared? 30 squared is 900, right? So 40 squared is 1600. So now you know for sure that this number 1024 lies between these two squares. Now next, let us see what is 35 squared. Okay, what is 35 squared? See, again in speed max, you remember we learned how to find 35 into 35. I said it is 1225. So how do we get it? These are complementary numbers. So 5 5s are 25 will be your last digits. This will be 3 into 4, 12. Correct? So 35 squared is 1225. Now the number that you are looking for, okay, is a square between these two. That is, the number is a square between 30 squared and 35 squared. Correct? Now 30 squared and between 30 squared and 35 squared, what are the numbers that you have? You have 31, 32, 33 and 34. Now check. It will be easier for you to check once you are able to narrow it down like this. Okay. So if you see 31 squared is I think 961, correct? So similarly, so you are left with 32, 33 and 34. Check which one will be the closest one. For this question, if you take 1024, we know that it is 32 squared. But generally, if the numbers are big, let's say I told you, 7,000, right? Such numbers come. What is the number that you add to 7,000 to make the perfect square? When such questions come, always try to do this. Try to find out two squares which you know closer to this number and try to understand which can be the possible squares and then check those. Then you will get the answer faster. Okay. So let's say, see, then you can again go with the options also. So you know it is either 31, 32, 33 or 34. Then check. Now if I put 1065, will that be any one square? See, okay, I have 1020, correct? So first option was 10 ending with 5. So none of these numbers will, squares will end with 5. So this option is ruled out. Again, take 12. Again, you can rule out 12 also directly because it ends with 2. See, even if I add 1020 plus 12, the answer that I get will be 1032. That is, a number ending with 2 can never be a perfect square. Remember that a number ending with 2 or 8 will never be a perfect square. So you can eliminate that option also. Now you are left with 1020 plus 59. Correct? And 1020 plus 4. So 1020 plus 59 will be 1079. So check what is 33 squared. Similarly, because only 33 squared can end with 9. Similarly, you have 1024 ending with 4. So only 32 squared can end with 4. So check those two, which is the closer one, take that as the answer. Okay, so that's how you actually go about solving this question when the numbers are big. Okay, see, for this particular question, don't solve it this way. As you said, you can go through the options and get the answer very easily. But if the question is like bigger numbers, 7056 is the closest square. Yes, so if the number is big, then you can follow this approach that I just explained. 84 into 84, very good. Next question is there on your screen. At the first stop on his route, a driver downloaded 2/5 of the packages in his van. After he downloaded another 3 packages at the next stop, half of the original number of packages remained. How many packages were there in the van before the first delivery? Again, it's just a one-step answer that you need. Even that step, if you are able to do the calculation in your mind, very good. But otherwise, just you have to write down one step to get the answer. See, this 2/5 of the packages that he downloaded plus the 3 packages together, they account for half of the total number of packages. Correct? Actually, yeah, you can write x. So this is equal to 2/5 x plus 3 is equal to half x. Solve for x, you get it as 30. So this is the only step that you actually require to get the answer. See, half packages he has remaining with him. What are the packages that he downloaded? That was the other half. Correct? So that is nothing but 2/5 of the total packages plus the 3 packages. So 2/5 x plus 3 is equal to half x. Directly you can get the answer. Yes, answer is option C, 30. So this is the just one equation that is required to get the answer. Next question. An army commander wishing to draw up his 5180 men in the form of a solid square found that he had 4 men less. If he could get 4 more men and form the solid square, the number of men in the front row is dash. See, again a very easy question. So what is happening? See, he has 5180 men with him. So when he is adding 4 men, correct, to that he is forming a solid square. So what does that mean? If he is forming a solid, arranging the people in a solid square, that means that if there are, let's say there are x people in the row, okay, in one row, in the column also they will have x people, okay. So the total number of people is nothing but x into x. Number of persons in one row into the number of columns, that is equal to x squared. So what is he saying? This 5184, that is equal to x squared, and you have to find the value of x. How many people are there in a row? Now, so what you should do, you should find the root of 5184. See, during the speed max section, I remember telling you go through the how to calculate the root of numbers, okay, square root. I hope all of you have gone through the videos. So at this point, one way to do is to go with the options, okay. Now go with the options means you have 5184, last digit of the square is 4. So the root of this should end with 2. So you can directly eliminate these two options. These two options are not correct. Now you are left with 72 and 82. You have to check which is the correct answer. Again, 80 squared you know is 6400, correct. So what is 82 squared will be greater than 6400, that much you know. So here you have only 5184. So definitely your answer has to be 72. But since there is none of these options also, what you do is 72 into 72, check it up whether you get 5184. Now I hope all of you know how to find the square root. Other than this, see, let's say the options are confusing, okay, in some manner you are not able to check with the options. So then how you do is, see, you have 5184. How do you find the square root of the number? See, the closest square root that you know here between these numbers is 70 squared, which is 4900. Similarly, what is 75 squared? 75 into 75, 25, 5625. Right, we again learned how to calculate 75 squared in our speed max class. So you know 75 squared is 5625. So your 5184 has to be between these two, correct. So and the only possibility that it can be is 72 squared. Again you will arrive at the same answer, okay. So the correct answer here is 72. Next question. If n be any natural number, then by which largest number n cube minus n is always divisible? See, this is a very good question. See, you have n cube minus n. How can I write this n cube minus n? I can write it as n into n squared minus 1. Correct, I am taking one n out. Or I can write it as n into n plus 1 into n minus 1. So I can split it and write it like this. Or this is equal to n minus 1 into n plus 1. Correct. Now what does this represent? This is nothing but the product of 3 consecutive numbers. Okay. It is given it's a natural number. So definitely it is either 1, 2, 3, 4, 5, 6, etc. Correct. So this is the product of 3 consecutive numbers. Now what can the numbers be? See, either 2 numbers will be odd and 1 number will be even. Let's say one possibility will be like this. The numbers are 3, 4 and 5. Something like this, where 2 numbers are odd and 1 number in the middle is even. Or the other way in which the numbers can come is 2 numbers are even, okay, and the number in the middle is odd. But when you see, take any combination and take any number that you want. I am just taking 2, 3, 4 and 3, 4, 5 to explain easily. Okay, any set of numbers that I take, I can always see that there will be one number which is divisible by 2 and one number which is divisible by 3. For sure it will be there, okay. So again 3, 2. So definitely I can say that any set of 3 consecutive numbers will be divisible by 6, okay. So because it is divisible by 3 and 2, it is definitely divisible by 6. So 6 will be the largest number by which this n cube minus n will always be exactly divisible. So the correct answer here is option B, 6. So these are product of 3 consecutive numbers. If you take product of any 3 consecutive numbers, one of the numbers will definitely be divisible by 3 and the other will definitely be divisible by 2. Okay, any case, any set. So I can definitely say that such numbers will always be divisible by 6. Next. If x and y are the 2 digits of the number 347xy such that the number is completely divisible by 80, then what is the value of x plus y? So if you know the divisibility rule of 8, solving this question is very, very easy. How will you solve it? What is the divisibility rule for 8? Now the number has to be divisible by 80 they have given, okay, xy. Now the number has to be divisible by 80 means definitely the last digit has to be 0, because then only it will be completely divisible by 80, correct? Because there is a 0 here, it has to get cancelled. So directly I can say y is equal to 0. Now you have a number 3, 4, 7, x and 0. You have to divide, the 0 is, okay, 0 is gone. Okay, 0 is there, correct? Now you have to divide this by 80. So how will you say that? See, 7x0, this 3 numbers, last digits has to be divisible by 8 for this number to be divisible by 80. It is already divisible by 10 because here this 80 is nothing but 8 into 10, correct? So here 0 is there, 0 is there. That criteria is satisfied. So I can say directly y is equal to 0. Now what should be the value of x? A number is divisible by 8 if the last 3 digits of the number is divisible by 8. So what is the only possibility that can come? See, we know 8 9s are 72. After that, there is no multiple of 8 in the 70s, correct? Then you have, after 72, then it's directly going to 80. So x has to be 2. Then what will happen? Then this will be 3, 4, 7, 2, 0 divided by 80. Okay, so the last 3 digits is divisible by 8, this is divisible by 10 also, so this number has to be divisible by 80. So the correct answer is A, that is 2. Next question. How many numbers are there from 300 to 650 which are completely divisible by both 5 and 7? So what is the answer for this? See, the number has to be divisible by both 5 and 7 means the number has to be divisible by 35, correct? 5 7s are 35. So numbers between 300 to 650 and it should be divisible by 35. How many such numbers will be there? Again, see, you know, how do you go about solving this? See, you know what is 35 into 10? 35 into 10 is 350, correct? So after 300, what will be the first multiple of 35? It has to be 35 into 9, correct? 350 minus 35 will be 315. So the first multiple of 35 after 300 will be 315, right, which is equal to 35 into 9. Similarly, now what is 35 into 20? See, 35 into 10, you know, is 350. Similarly, what is 35 into 20? That is equal to 700. So this also you know. Now, so the multiples that we are looking at are multiples less than 20. So we need multiples less than 650, correct? So after between 650 and 700, there will be only one multiple of 35, that is 35 into 19, correct? So now let's check what is 35 into 18. What is 35 into 18? You get 630, correct? Again, see, again that is very easily you can do because you know 35 into 20 is 700. 35 into 2 you know is 70. Correct? See, these are the cases where if you know the concept of speed max, it's very easy, okay? So, you know 35 into 20 is 700, correct? 35 into 2 is, you know, 70. So, to find 35 into 18, you just subtract 700 minus 70, that is 630, okay? So, 630 is 35 into 18. So, that is going to be our last multiple that we require, okay? So all the multiples of 35 from 9 to 18 are the multiples between this set of numbers 350, 300 and 650 which are divisible by 5 and 7. So how many such numbers are there? See, it is 10 such numbers are there. Shrey, see, how do you say 9? It is 10. See, you have 9, correct? 35 into 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Because you have to include this 9 and 18, correct? Because they are also within the limit only. So totally you will have 10 such numbers. So the correct answer here is option C, that is 10. Is it clear? So the correct answer is option C, that is 10. Next question. If the sum of the digits of any integer lying between 100 and 1000 is subtracted from the number, the result is always dash. So for such questions, best way to do it will be take some random numbers and check it out. Take the random number and get the answer. Take any two numbers. Let's take 123. Okay, one random number I am taking. So do 123 minus 6. Correct? Sum of the digits, because sum of the digits is 1 plus 2 plus 3, that is 6. So 123 minus 6 will give me 117. Now 1 plus 7, that is 9. So 9 is divisible by This 117 is divisible by 9. Okay. Take one more number. Always don't stop with one number. Try one or two random numbers to be sure that that is the answer. Similarly, take another number. Let's say 361. Okay. Now, if you take 361, 3 plus 6 plus 1. That is 3 plus 6 is 9. 9 plus 1 is 10. So, 361 minus 10 will give you 351. Add these digits, you get 9. So, this number is also divisible by 9. So, all such numbers will be divisible by 9 and the correct answer is option D. Next question. The product of two successive numbers is 9506. What is the smaller of the two numbers? Very easy question. Best way to solve this question is to just check with the options. See, you have two numbers, we have to find out the smaller number. So, if 96 was the smaller number, then what will be the bigger number? It has to be, see, basically what you are doing n into n plus 1. One number, smaller number into the next number, correct? 96 is the smaller number, then the next number is going to be 97. But when you do 6 into 7, the last digit has to be 2. Here the last digit is 6. So, this is not your answer. Similarly, if you have 97 into 98, correct? Here 7 8s are, last digit is 6. So, this can be the correct option. If you have 98 into 99, again 8 9s are 72. So, last digit is 2. So, that is not your answer. Again 99 into 100, that definitely cannot be the answer. Last digit will be 0. So, this seems to be the only valid option. Now, just multiply this and see and cross check if you get the answer as 9506. Okay. So, the correct answer here is option B, that is 97. The smaller number is 97 and the next number is 98. Next question. Product of two coprimes is 117. Their LCM should be dash. So, if you know the definition of coprime, this question is an easy question. In 1 second, you will get the answer. What is the answer for this question? So, it's a straightforward question. No calculation, nothing to be done, just you have to give me the answer. So, if you have any two numbers, correct, whose let us coprime. So, the example that we took first was 22 and 9, correct. Now, there are no common factors here. So, when you are calculating the LCM, the only way in which you can calculate the LCM is multiply these two numbers. That should be the LCM of these two numbers, okay. So, that will be the least common multiple, because anyway they don't have any factors in common. So, definitely you will have to multiply the two numbers to get their LCM. So, here if the product of two coprimes is 117, then their LCM is also 117. Yes, good. Next question. So, see, look at this question. The question says the units digit in the sum of 124 to the power 372 plus 124 to the power 373 is dash. So, how many of you know how to solve questions wherein you have powers and the unit digit of these powers is asked? Any of you know? See, for clerk's examination and all, I don't think such questions will appear, but it is good to know such methods. If you are preparing for SSC, CGL and all, these questions you can expect in the examination, okay. But anyway, it's a very easy method. I'll teach you today, and I think once you learn the method, solving such questions become very, very easy. So, any of you know this method? See, let us say I am asking you a question, okay. 2 to the power 65. Now, what is the last digit of this 2 to the power 65? So, if I say 2 to the power 10, what is the last digit of 2 to the power 10? I know 2 to the power 10 is 1024. So, I can say the last digit is 4. But when such a question comes, how do I answer it? So, generally there is a method called as a cyclic pattern that these numbers follow to answer such question. Now, let us take the number 2, okay. So, what is 2 to the power 1? 2. 2 to the power 2? 4. 2 to the power 3? 8. 2 to the power 4? 16. Then you have 2 to the power 5, that is 32. 2 to the power 6, that is 64. 2 to the power 7, that is 128. 2 to the power 8, that is 256. Now, if you see the number 2, again if you write 2 to the power 9, it will be 512 and so on. Now, when you look at these, what can you see here is that the powers, right, of this number 2 follows a cyclic pattern. See, 2, 4, 8, 6. Last digit, look at the last digit, 2, 4, 8, 6. That keeps repeating. Here also it will be 2, then its last digit is going to be 4, and then 8, and then 6, and so on. So, generally these numbers, they will follow a cyclic pattern, okay, when it comes to the last digit. So, if you know that pattern, solving such questions become very easy. See, what can I say? The power, right, look at the power. If the power like let's say any number, 2 to the power some number, correct? Now is this power is a multiple of 4, then the last digit will always be 6, correct? Because you can see that pattern that is being followed here. If you have 2 to the power 12 here, that will definitely end with a 6. Might be you can just cross check with your calculator. It will definitely end with a 6. So let's say I have a question says 2 to the power 64. So what will be the last digit of 2 to the power 64? It has to be, see, 64 is divisible by 4, correct? 64 is a multiple of 4. So definitely I can say that the last digit of this power is going to be 6. Okay. Now similarly, if the question is they are asking me what is the last digit of 2 to the power 65, then what do I do? So again this cycle has to repeat, correct? 2, 4, 8, 6. Then next, this is 2 to the power 64 will end with 6. So 2 to the power 65 should end with the 2, because the closest multiple of 4 near 65 is 64. So 64 will end with a 6 and 65 should end with a 2. Okay, this is called as the cyclic pattern. Similarly, if you see the number 4, you can write this for any number. Okay, now 4 to the power 1. Okay, because in this question we need 4, I am writing 4. What is 4 to the power 1? 4. 4 to the power 2, 16. 4 to the power 3 is 64, correct? Again 4 to the power 4 is 64 into 4, that is 256, correct? Yes. So again if you look here, the pattern that is being followed is 4, 6, 4, 6. So that keeps repeating. So for every odd power of 4, that is here, every odd power, it will end with a 4. Every even power will end with a 2. Okay. Now there is a table that you can make with all the numbers like this. Okay. So similarly, if you are taking the number 3, what will happen? If you are taking the number 3, 3 to the power 1 is 3, 3 squared is 9, 3 cube is 27, correct? 3 to the power 4 is 27 into 3, that is 81. 3 to the power 5 is 81 into 3, that is 243. So same pattern, 3, 9, 7, 1, that will again keep repeating, 3, 9, 7, 1. So the pattern for 3 is 3, 9, 7, 1. So if you know this pattern, you can say. So if I am saying the question is, let us say 3 to the power 64. What is the last digit of 3 to the power 64? See, the cycle of 3 is that in every 4 steps, this pattern repeats, 3, 9, 7, 1. 64 is a multiple of 4. So definitely it has to end with a 1. Correct? Or if the question was 3 to the power 62, then what will it end with? See, you know, the closest multiple of 4 near 62 is 64. So I know 3 to the power 64 will end with 1. So 3 to the power 63 will end with 7 and 3 to the power 62 will end with 9. So this is the method, okay, that you have to use to solve this question. Now let us look at this question here. So for this question you have 4 to the 124 to the power 372. So if you look at the last digit here, it is 4, correct? So what is the last digit of 4 to the power 372? Again look at this 372. Is 372 divisible by 4? Now let us look at the steps of 4. What did we write? 4 to the power 1 is 4, 4 squared is 16, 4 cube is 4. 64, 4 to the power 4 is 256. Basically, the pattern of 2 is 4, 6, 4, 6, correct? The pattern of the powers is like this. So, what can I say? Any even power of 4 will end with 6 and any odd power of 4 will end with 4. So, you have an even power here. So, this has to end with a 6 for sure. Now, next one. You have 124 to the power 373. Correct? Here it is an odd power of 4. So odd power of 4 will always end with a 4. So the last digit of this number has to be, it should end with a 4. So what will be the sum of the last digits of these two numbers? It will be 6 plus 4 or 10. That one will go as carry to the previous step. So it's going to be 0. So the correct answer here is option D. Okay? Each number, let us say generally numbers like 2, 3, 4, 5, 6. Right, they follow a cyclicity when it comes to calculating their powers. So if you're taking the number 2, right, the last digit of the power will always repeat in this pattern, 2, 4, 8, 6. Similarly, if you're taking the number 3, this pattern will keep repeating, 3, 9, 7, 1. Similarly, if you take the number 4, the pattern 4, 6, 4, 6 will keep repeating. Okay, if you take 5, everything will end with 5. No problem, same answer you will get. If you take 6, a power of 6 will always end with 6. So if the question is like this, 126 to the power some number 365, what is the last digit? Here 6, any power of 6 will always end with 6, directly you can say. Okay, so again if you have the number 7, right, 7 will always follow this cycle, 7 9 3 1. 8 will follow this cycle, 8 4 2 6. Similarly you have 9 will follow the cycle, 9 1, that will keep repeating, 9 1 9 1. So if this see, for the numbers that has only 2 steps, correct, see, look at 4 is 4 6 4 6 4 6. So for any odd power the last digit will be 4, and for any even power the last digit will be 6. Similarly, when you take in case of 9, for any odd power the last digit will be 9, and for any even power the last digit will be 1. In all the other cases they are following a cyclicity of 4, correct, because there is a pattern, 4 numbers, then again the same 4 numbers keep repeating. So generally we check if the given power is divisible by 4, and using that we try to find out what will be the last digit. Okay, so this is the method. Now, if you are preparing for SBI clerk, some of you said you are preparing for SBI clerk and all, right? So, till now such type of questions haven't appeared in clerk's examination and all, but you never know when they will introduce such questions in the examination. So, good to know these methods, and generally till now these such type of questions I have very commonly seen in SSC CGL papers. That's where I have seen this questions to be very common. Okay, now next question. But if you actually see, these are very easy questions. Once you understand the concept, right, you don't even have to remember these cyclicity, what is the cyclicity and what will be the last digit. You know the powers, right, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So even in the exam itself you can work out and get the correct answer, right. If, you didn't remember that the cycle of 2 is this, the cycle of 3 is this. At times you will not be able to remember, correct. Cycle of 3 is 3 9 7 1. If you are not able to remember also, that's fine, but if you know this concept, solving it becomes very easy. Next question. If 17 to the power 200 is divided by 18, the remainder is dash. Again a complex question, but which can be solved in a very easy way if you know the method. Okay, so I'll also teach you how to do such questions. See, in this session I am trying to cover all difficulty levels for you so that you are well prepared with the topic number system. Next time you hear number system, you should not tell me that I have never seen a question like this. Okay, so we did a few easy questions, we did a few moderate questions. These questions also you will be able to solve if you know the method. So any of you know how to solve this question? See, to solve such questions there is a something called as a remainder theorem. Okay, I'll just write down that theorem here for you. If you apply this theorem, you will get the answer in one step. Okay, so the theorem is this. I'll explain the theorem also. When you read it, you might find, oh my god, what am I trying to say? But it's actually very easy. Yes, so if you know this theorem, solving this question is very easy. So what does it say? So if I have a polynomial, that is f of x, and I am dividing it by a factor, let's say x minus a. Okay, I am dividing it by some x minus a. The remainder that I get for this division is always equal to f of a. Now how am I going to apply it in this question? See, I have 17 to the power 200 divided by 18. So whenever such question comes, we have to try to represent the denominator in terms of the numerator. Okay, so how can I write? I can write this as 17 to the power 200 by 17 plus 1. Basically I am trying to bring it to this form. Okay, f of x by x minus a, so that I am able to get the answer faster. Okay, so I am just writing this as 17 to the power 200 by 17 plus 1. So if I take 17 is equal to x, if I take 17 is equal to x, what am I getting? I am getting x to the power 200 divided by x plus 1, right? So basically this is a polynomial f of x, I am dividing it by some x minus a, correct? So what is my remainder going to be? My remainder is going to be f of a. So here if it is x minus a, it is f of a. So here it is, see, it is minus of minus 1, correct? So what is my remainder here for this division? It is going to be f of minus 1. Okay, what is f of minus 1? Just put minus 1 in this polynomial. What is your f of x here? Your f of x is x to the power 200. So in this put x, instead of x put minus 1. So minus 1 to the power of 200 you know is equal to 1. Correct? So the answer for this question is 1. That is option A. Let me explain it to you once again. See, whenever such question comes, you have to remember this remainder theorem. Okay, when you are dividing a polynomial f of x by x minus a, your remainder is going to be f of a. So here you have 17 to the power 200 divided by 18. So that is equal to 17 to the power 200 divided by, I am trying to represent the denominator in terms of the numerator. So I can write this as 17 plus 1. Correct? So that is how 18. Correct? Now what did I do? I have to represent it like this. Correct? So I just took this 17 to be x. To basically try to apply this formula. So if this is x plus 1. Correct? So x to the power 200 by x plus 1 is of this formula. And then what is given here, if this is the case, then your remainder is going to be f of minus 1. So for this numerator, apply minus 1. So minus 1 to the power 200 is equal to 1. That's your answer. Okay. Now for this type, so that you guys are familiar with this method, let me give you one more question. Okay. Let me delete this. So I have not taken a question separately. Let me give you a question. So what is the remainder of 2 to the power 42 divided by 7? How will you do this? Can you guys try it on your own now using the same method that I discussed now? 2 to the power 42 divided by 7. How will you do this? See, the remainder theorem says that if you do f of x by x minus a, then the remainder that you are looking for is given by f of a. So basically what do we do? You try to represent the denominator in terms of the numerator. Correct? Here you have 2. So this question is a bit tricky, a small change you need to make. Any of you are able to do it? What will be the remainder? See, what you need to do here is, I told you represent the denominator in terms of the numerator. How can I represent? I have to represent 7 in terms of 2. The only way in which I can represent is 2 cube is 8. Correct? So this is 2 cube minus 1. This I can so write it as, again numerator I can write it as 2 cube whole to the power 14. Correct? 14 3s are 42. 2 cube minus 1. So this is equal to, I am taking 2 cube is equal to x. So I write it as x to the power 14 by x minus 1. Correct? So again, some of you are giving me some answers. So this is your polynomial, correct? So this is f of x by x minus a. So what is your remainder going to be? Your remainder is going to be f of 1, correct? X minus 1, so f of 1. So x to the power 14, in place of x I have to put 1. So 1 to the power of 14, that is equal to 1. So 1 will be the answer for that question. Next question. Hope it's clear, guys. Please respond and tell me that you understood. The next question is on your screen. The number of prime factors in the expression 6 to the power 10 into 7 to the power 17 into 11 to the power 26 is dash. Now next, this type of question is always confusing for a lot of students. When such question comes, there are 2 or 3 cases. I'll explain it to you one by one. So for this particular question, what is the answer? The number of prime factors in the expression 6 to the power 10 into 7 to the power 17 into 11 to the power 27 is dash. See, they are asking for prime factors. 7 is a prime number, 11 is a prime number, 6 is not. So I have to split this as 3 into 2 to the power 10. Correct? That is equal to 3 to the power 10 into 2 to the power 10. 3 and 2 are prime numbers, correct? So I can write this expression as 3 to the power 10 into 2 to the power 10 into 7 to the power 17 into 11 to the power 27. Okay, so these are the prime numbers, prime factors. In terms of prime factors I have expressed. Now number of prime factors that are there is, see, 3 is a prime factor which is appearing 10 times. So there are 10 prime factors here, correct? Similarly 2 is also appearing 10 times, 17 times, 27 times. So the total number of prime factors is 10 plus 10 plus 17 plus 27. So the answer is what? 17 plus 27 is going to be 44. 44 plus 10, 54, 54 plus 10, 64. Correct answer here is option B, 64. See, one thing you have to note here is that they have just asked the number of prime factors. So this 3 is appearing so many times, right? You consider everything as one prime factor and take. But let us say sometimes in questions what they ask is, how many unique prime factors does this expression have? Unique prime factors means the repetitions you will not take. Okay, so unique prime factors means, see, 3 is one factor, 2 is one factor, prime factor, 7 is one prime factor, 11 is one prime factor. So if they ask for the word unique is mentioned in the question, there are only 4 unique prime factors for this given expression. But if they are just asking you for the number of prime factors, add all of them up. Next question. So I think with that we are coming to the different types of questions that has been chosen for number system. Okay. Now the next topic that we are going to be doing in today's session is number series. Now coming to number series, there are 2 types of questions that generally come in the examination. One is to find the missing number in the given series, and the other is wherein you have to find out the wrong number or a wrong number in the given series. So again, see, when it comes to number systems and any other topic, right, lot of topics, we have a lot of shortcuts that we learn. Using these shortcuts you can arrive at the answer, but number series is one topic wherein there is no shortcut to arrive at the answer. The only way in which you can solve these questions is with practice. So when we practice a lot of questions from this type, generally when you look at the question itself, you will get an idea of the series, and many times the series appear in the exam in such a way that cracking the series is very difficult. So choose the questions from number series very wisely. See, read the question, never leave any question, go through the question and see if you are able to crack it. If you feel it is taking too much of your time, please skip such questions, okay, because sometimes how much ever you think, we will not be able to arrive at the the pattern that is being followed. And again, with practice, many times we will be able to say this is the pattern by just looking at the question. So that also happens. So choose the questions wisely always from number series, because questions on number series commonly appears in all the exams, right? Sometimes you have 5 to 6 questions that come from this section. So a lot of times with practice itself you will be able to get the answer, as I said, but again, choose the questions wisely. If it is taking too much of a time, don't waste your time, move on to the next question. The first question from number series is there on your screen. Again, questions from number series can be of different types. Let's just talk about that also before we solve this. See, either it will be, you have some trivial series, right? Like wherein you have to find the cube, that is cubes of numbers are given, squares of numbers are given. So such series are very easy to crack. Similarly, you will have 1 or 2 operations mixed, like into 2 plus 2, into 1 minus 1 plus 1. So on, right? Mixed series will be there. Again, you will have alternating series. Now, what are alternating series? There will be 2 set of series that are there. Okay, so you will have to segregate the 2 set of series and get the answer. So these are the various types that can generally come from number series. So actually, what I would suggest is please go through the workbook and try to solve questions that is there in the workbook, and you will get an idea of the different types that can come. Okay. Now, give me the answer for this question. 26, 12, 10, 16, question mark. What will come in place of the question mark? Basically, you can see that it is decreasing, correct? 26, 12, 10, no, then again there is an increase. So, see, these are a bit complex series. I have taken little complex series also so that you get an idea. So, so 26 by 2. 13, correct? Minus 1, sorry. Minus 1 is 12. 13 minus 1 is 12. Now, next one is 12 into 1 minus 2. 12, 1 is 12 minus 2 is 10. Next is into 2. 10 to the 20 minus 4 is 16. So the pattern that is being followed here is this. See, into 0.5 minus 1, into 1 minus 2, into 2 minus 4. So 0.5, 1, 2. So next is going to be 4 minus 8. Basically, you are doubling each thing, correct? So here 0.5 plus 0.5 is 1, 1 plus 1 is 2, 2 plus 2 is 4. So next will be 4 plus 4 is 8, and so on. So here it is going to be into 4 minus 8. So that is 16 into 4, 64 minus 8, that is 56. So the required number here is option D, that is 56. Okay, I hope it is clear. See, these are, as I said, a bit complex patterns, but again, if you practice by looking at the pattern, you might be able to identify it faster. Next question. 82, 107, 207, 432, 832, question mark. What is the logic for this question? So you have 82, 107, 207, 432, 832 and question mark. So the pattern that is being followed here is, see, 82 plus 25 is giving you 107. 107 plus 100 is giving you, this is plus 225 plus 400 and so on. So what is this actually? 25, 100, 125, 400. See, this is 25 into 1, that is equal to 25. 25 into 4 is equal to 100. 25 into 9 is equal to 225. Similarly, 25 into 16 is equal to 400. So what should come here? See, 1, 4, 9, 16. So next should be 25. Basically squares, correct? So 25 into 25. So that should come here, that is 625. So here it should be 832 plus 625. So what is that? 832 plus 625, the answer will be 1457. 1457, that is option C. Next question. 122, 213, 340, 509, 726. See, when you look at this question itself, you can see that there is some relationship between the squares or cubes of numbers. So we have to identify that here. Actually, the cubes of numbers. So you have 122, 213, 340. Check if there is any relationship between these numbers and the cubes of numbers. Can you find out some relation? See, what is 5 cube? 125. 125 minus 3 is 122. Similarly, what is 6 cube? 216. 216 minus 3 is 213. 7 cube minus 3. Correct? 8 cube minus 3. So this is 9 cube minus 3. So the next one will be 10 cube minus 3, that is 1000 minus 3, 997. So the correct answer is option B. See, such questions, no, if you actually, we have solved now in the class. Now when you see similar questions, you will be able to identify the pattern faster. Next one, 40, 54, 82, question mark, 180, 250. Fairly easy pattern this is, okay. What is 54 minus 40, that is 14. 82 minus 54, 28. Okay, so that's the pattern, correct. 40, 54, 82, 180, 250. So here the difference is 40 plus 14 is 54. 54 plus 28 is 82. So here it has to be 28 again plus 14. If you do, you will get 42, correct. 42. That plus 56 should give you 180 and so on. So 82 plus 42 will be 124. So the required answer here is 124, that is option B. So 124 plus 56 gives us 180 and so on. So that's the pattern here. The next question, see the wrong term. Again, the most difficult thing when it comes to number series is identifying the wrong term. See, even the completing the series, right, very easy to do many times. But again, identifying the wrong number is the difficult part. Now this particular question, since we have solved some questions of similar type previously, let me see if you are able to identify. The question is this, the wrong term in the sequence 7, 28, 63, 124, 215, 342, 511 is dash. See, it is similar to one of the previous questions that we solved. A similar logic, not the exact logic, but a similar one, yes. Actually the exact logic too, yes, it's the exact logic. So can any of you identify what is the odd number here? So see, what is 7? 2 cube minus 1, correct? 63, 4 cube minus 1, 124, 5 cube minus 1 and so on. What is 28? It is actually 3 cube plus 1. So this is definitely the odd one. It should have been 26, correct? 3 cube, that is 27 minus 1. It should have been 26. So the wrong term here is option B, 28. Now since we have done a series like this previously, right, when you look at the numbers 7, 28, 63, 124, so all of these numbers are closer to cubes of numbers. So you put in, you just cross check again, you will get 2 cube minus 1 is 7. Similarly, 4 cube minus 1 is 63 and so on. So that is, it is difficult for most of us because sometimes questions are difficult that we are not able to identify the pattern. Best thing to do when it comes to exam for such questions is skip the questions, because don't waste your time finding out the wrong number, okay. But like for this particular question, if this question comes in an exam, you will be able to identify it, right. So practice more questions and check, and if it is still difficult, skip the question, because sometimes identifying the wrong number is more difficult than doing the finding out the missing number. See, some of the series are easy, and again let us look at the next series. And the biggest issue comes when the wrong number is the first number, because if the wrong number is in between, we'll be able to find out the pattern and arrive at the answer. But sometimes what happens is the first number will be the wrong number. So that makes it even more difficult for us to analyze and get the answer. But there are no shortcuts or no specific method that you can follow. Next question. 7, 8, 18, 57, 2, 28, 1, 1, 6, 5, 6, 9, 9, 6. See, 7 into 1 plus 1 is equal to 8. 8 into 2 plus 2, that is equal to 18. 18 into 3 plus 3 equal to 57. So this is the pattern that is being followed. So next one will be 57 into 4 plus 4. So if you look here, 7 4s are 28. So last digit is 8. 8 plus 4 should end with 12. Here you are having 228. So this is your wrong number. 228 is your wrong number here. That is option D. Yes, a lot of you have given me the correct answer. Very good. Wrong number is 228. See, these are very basic patterns. So into 1 plus 1, into 2 plus 2. In a lot of exams you see such patterns. So if you know such patterns, you can try and apply them in the given questions. Next question. Now, find the wrong number in this series. So I think this was a question that was asked in SBI clerks. I don't remember the year though. 196, 169, 144, 121, 180, 64. Which is the odd word? Very easy question, no? See, 196 is, yes, 12 squared, 11 squared, 10 squared. So this is the odd one. It had to be 81. It is 80. It's not a perfect square. Very good. Very easy question, right? So if such question comes, don't miss it. These are mark scoring questions. Okay. So I think with that we have come to an end of the questions that we have chosen for today's session. So all the very best with your preparations. And one more thing I want to tell you all is, see, we are providing you these weekly tests, weekly AIMs and other full length papers that are being enabled in your account. We also provide there is daily practice tests. Okay, if you go to the study plan course, there is a section called as daily practice, wherein we are giving you speed max tests, subject wise tests, etc. Please be regular and answer these questions, take up these tests regularly. Taking up tests is a very, very important part of your preparation. Okay, so all the very best with your preparations, and I'll see you in the next session. And this is Gayatri signing off till then.